Number one, the graph of f prime is given, and we know that f of 0 equals 0. Which of the following must be true? So I'm asking about what? F, and I give you f prime, and I said f of 0 equals 0. So if I'm asking about f, how do you go from f prime to f? The integral, yes, but what am I asking for? Essentially, if I just take the integral, I'm not finding f. Think of the context. Parent function, maybe? Maybe that's a word. When you take the integral, are you finding the position? No, you're finding the what? Displacement. So if I want position, how do I find position? What's the equation for position? The initial condition plus the integral from what? 0 to x of what? F prime of t. Now, in this case, the initial condition is 0, so that kind of goes away. But what is greater? Is f of 0 greater or is f of 1 greater? Come on. F of 0 is what? 0. What's f of 1?
Greater than 0.
You could look at it this way, the integral from 0 to 1 of f prime. So what am I trying to find?
The area under that.
The area under the curve. What do I know about the area under the curve from 0 to 1? It's positive. So f of 1 is greater than 0. And you can look at it this way. What can we say about f prime in that graph? F prime is positive. Therefore, f is increasing. Well, if f is increasing from 0 to 1, then f of 1 has to be greater than 0, right? So option 1 is true. What about option 2? Is f of 2 greater than f of 1?
Yeah.
Yes, because again, f prime is positive from 1 to 2, therefore f is strictly increasing from 1 to 2. Therefore, f of 2 has to be greater than f of 1, right? The problem I think we ran into was the third one. Is f of 1 greater than f of 3? Well, let's look at it this way. We know f of 1 is greater than 0 based on this. Let's find f of 3. What's f of 3? The integral from 0 to 3 of f prime of t dt. So what is the integral from 0 to 3? We don't know, but I could argue this. Isn't this the same as saying the integral from 0 to 1 of f prime of t dt plus the integral from 1 to 3 of f prime of t dt? Agreed? Well, what was this one? What? What is it, though? It's f of 1. So the question is, we know, let's pretend we know this number. It is positive, we don't know how positive, but let's pretend we do. What is the integral from 1 to 3? Is that going to be positive or negative?
Positive.
How do you know?
Because the area under the curve is
Because the integral from 1 to 2 is greater than the integral from 1 to 3, right? Or it's a greater absolute value, right? The area above is greater than the area below, therefore, this region is positive. And we knew this region was positive. So what can we say about this whole thing? It's going to be positive, but is it going to be bigger than f of 1 or not? Yeah, because this piece is positive, right? So we could say f of 3 is what? Greater than f of 1, which makes 3 false. So it's just 1 and 2 deep. Now number 2, let's see how, give me some ideas. What did you guys do? Well, I copied off of him, and he copied off of her, and I don't know where it came from, but I heard something, and I put it. I'm wrong?
Wrong for number 1. You said f of 1 is greater than f of 0, but that was right, but that's not on there.
Oh.
That's just B. You said it was D. If you,
Oh, I re- okay,
if you
okay,
look back
fair
on
enough,
your
fair
video, you'll see that.
No. F of, wait, 3 was wrong though, wasn't it?
Yeah,
3's wrong.
1 is wrong.
1 and 2 were right.
1, I said f of 1 is greater than f of 0. Okay, so 1 is not wrong. 1 is not correct. Therefore, it's just B. There, I corrected it on my video. All right, number 2. Can somebody please run me through what you were thinking?
Listening to.
Oh, that's about it right there, huh?
Can you take the derivative and find the...
Okay, let me do this. We're going to graph this. We've got the graph of cosine, right? Something like that. And we are looking from 0 to pi. So pi is here. Okay, so we're only looking at that region. That's the graph of cosine. And k comma cosine of k, we're looking for the tangent line at that point, wherever k is. So k is somewhere on this curve, where what? Where the tangent line passes through the origin. So if I were to draw the tangent line, how would I make it pass through the origin? Roughly, where would it be? If it was pi over 2, that'd be here, right? Would that line pass through the origin? Where's the origin? There. So where would the tangent line have to be to pass through the origin? Up here? Down here, right? Now, I know maybe some of you are confusing this. If this was the t-axis and this was the x of t-axis, then the origin is represented by the t-axis in an application problem. But that's not the case here. This is the what? This is the x-axis. This is the y-axis. So the tangent line is going to be something like this where it passes through the origin. So we can kind of visualize it graphically. We're looking for this point. This is k, comma cosine of k. Agreed? You okay with that? How would we solve that? Okay, how would we find the slope? Okay, what's the slope of y equals cosine of x? Okay, you take the derivative, you mean? Okay, y prime equals negative sine of x. Well, what does that do for me?
Isn't that the add?
That's the slope of the tangent line, right? Okay, what do I do from there?
Equation y equals x plus because doesn't it pass through the origin, so wouldn't y
Okay,
be zero?
so we have a couple things. We could say, we could create the tangent line. Remember the tangent line's y minus y1 equals m times x minus x1, right? Now, do we know m? No, we just know this function, right? Actually, what is y prime? At the point of tangency. What's the point of tangency? Okay, so what am I going to do to find the tangent line at that point? So it's going to be negative sine of k. So that's my slope there. So y equals negative sine of k times, well, what are my coordinates here? What's one coordinate? Y minus cosine of k equals negative sine of k times x minus k. Now I'm looking for k. Looks pretty good so far except for what? We have a y and x value, right? So what else do I know?
It passes through the origin.
It passes through the origins. That's another coordinate. So I could plug in 0 for y here and 0 for x. And then simplify it from there. So we got negative cosine of k equals negative sine of k times negative k. Okay, so that's negative cosine of k equals k times sine of k. How am I going to solve that?
Can you divide and cosine over sine is something?
That's going to make this 1. I don't want that. Make it 0. 0 equals k times sine of k plus cosine of k. And now what? Uh-oh. Graph it, find the zeros. Do it. Every one of you got it wrong, so every one of you do it. So we got k equals, what is it? 2.798. You guys agree? Are we okay with that? No, I'm not okay with being wrong, but are you okay with? So we're looking for the tangent line that lies on this curve, and the tangent line has to pass through the origin. So this is the point We just have to figure out what it is. So I've got to create that tangent line. I create that tangent line by knowing the slope and the point, right? So I know the slope by taking the derivative. So I took the derivative of the curve, which is negative sine of x. I plugged in my point of tangency, so that is my slope at k. So I plug that into m, and then I plug in my point to create the linear equation. So this is my linear equation, and now I know another coordinate because it passes through the origin is 0, 0. So I just plug that in and then solve from there. You okay with that now? That's an interesting one, huh?